Welcome to the Church of Mabus radio show. It's Friday night, 7:07 p.m. Central. Yes, I survived the hurricanes. The Helene went over us, and it was scary, crazy, but it rained a lot. But really weird. When I went out, there's like no wind, but the big band was passing over us. But it was like, where was the wind? It was strange. But luckily, it moved up, it was not lucky for a lot of people, but for me, apparently it didn't affect us, but the rain was bad. It was flooding and horrible. And I'd been through Michael, so it's kind of like you relive all that stuff when they're that close. And then you're watching Milton, which was just totally insane. And that was nowhere near me, but horrible, scary. Just watching that, man. The thing looked like a giant. Someone's passing around something, or it looked like a skull spinning down there or something. It was like the devil. It's one of those Jupiter hurricanes, for sure.
It was big. Wow, it was huge.
But I was like, we need to win the lotto and move out of Florida. But you're not safe anywhere from all this crazy climate stuff lately, no matter where you go.
The one before Helene went so far up north. I mean, it hit mountain towns that do not have logistics for, unflooding people.
And tonight's guest, Charles Liu, quantum physics, the handy quantum physics answer book. And man, I love the book. I've always loved Visible Ink Press, and they put out a lot of good stuff. But I was looking through your bio, like your rap sheet, and Neil deGrasse Tyson, Harvard. I was like, man, I gotta wake up. I need a BC powder.
I'm just this guy, Jeffrey. We're just all having fun together. It's all good.
Definitely, and we were already talking about comics, so I'm good. But very comfortable and laid back, and we just want to learn. Tell us about some of this. I know you were saying some stuff about the weather phenomenon that you've taught and stuff. Like, go into some of that hurricane stuff a little with us that you were talking about.
Yeah,
that was fascinating, actually.
Yeah, if you do the calculations and you do the measurements, it turns out, now, no quantum involved, the amount of energy in hurricanes is just huge. For example, Helene, you can read up in the news, they estimated, all the scientists did who were doing the weather measurements, that about 40 trillion gallons of rain fell. And if you take 40 trillion gallons, convert it into water of a certain amount of mass, and you drop it from, a mile or so up from the sky and let it hit the ground, the total amount of energy would be equivalent to more than 100,000 Hiroshima atomic bombs. So there's so much energy in these things, just in the water alone, that is no wonder that there's tremendous amount of damage. And then if you, like you said, Jay, if you go up into the hills and let it run down the hills and just hit towns that aren't used to it, it's going to just devastate as it did like Asheville, North Carolina.
They simply don't have the logistics for doing it. Florida is in the, the firing zone. So they have, that stuff on hand in their emergency services and whatnot.
That's right.
And mountainous, they have snowplows. Yeah, they dig themselves out of any kind of mud, maybe. But
that's right. Well, Florida's advantage to some extent is that it's flat. It's so flat that even if you have a lot of flooding, you don't have a lot of downhill runoff. So the water sits and it causes problems.
A hill to be found anywhere unless it's been built by man in the state. I've been there. We lived there when I was a child in the 70s, like for 3 or 4 years. I don't remember much of it, but the weather was always pleasant, but no hills.
Yeah.
When
I had heard that down the peninsula, like from Orlando on south, the highest thing in the topography was Space Mountain in Disney. That was what I heard when I was a kid. So it's really quite remarkable.
Probably true, because it's not mountain sized, but it's very large.
Right.
And that's the first place. Whenever I go to Disney, that's the first thing I hit. I hit it at least 3 or 4 times right there. This is the best roller coaster on the planet.
Well, there was one time when we were in line and the lights came on inside because there was a mechanical failure, so they had about half hour to fix it. And during that time, me and my kids, we were just kind of looking up there because my wife was like with our baby outside. And the other 2 kids and I were looking, and the roller coaster looks pretty good just by itself. If it were just by itself, it'd be amazing. But then you turn the lights out, and it just turns into this amazing joyride, which I have loved every time I go to.
I've seen video of, I guess, behind the scenes of the cars going with no people in it,
Oh.
and they come very, very close. I mean, if without the lights, you don't see the other cars when they come by you. But with the lights on, I mean, you could go, well, bam, and high five the guy in the car going the other direction. That's how close those cars go. They've engineered that track so precisely.
Amazing.
Yeah. It's a beautiful ride.
It is amazing. But, I was talking about the 100,000 atomic bombs worth of just kinetic energy from the rain. But what I was telling you, even more amazing, is the amount of heat energy in the atmosphere, right? Hurricanes, as you guys know, are carried from tropical areas, hot water, Gulf of Mexico, South Atlantic Ocean, Mid-Atlantic, or Equatorial Atlantic Ocean area. And they're carrying this heat in the form of water vapor. They vaporize the warm water. It goes up and gets carried over, and then it gets dropped, right? When it gets to colder climates, the water winds up cooling down and turning back into water droplets, liquid, and then they fall. And then the heat of vaporization, right, which was carried up originally from by the hurricanes from the tropics, winds up making the wind and making all the other storm-like activity energy that comes out. And that's even more than the 100,000 atomic bombs of stuff coming down. In fact, if you make a quick calculation, those 40 trillion gallons of rain, right, overall actually were carrying enough heat equivalent to more than 10 million Hiroshima atomic bombs. And
the entire state should have incinerated instantaneously.
That's right. The only reason it wasn't is because it was spread out over a large area and over a long period of time. Right. Instead of a bomb going off in a fraction of a second and being concentrated in a local
overwhelming the area,
spread over hundreds of square miles and over days and days. So that's the only reason why, we weren't all incinerated, but the amount of energy is extreme, which is why, when somebody says, yeah, well, maybe we'll just divert a hurricane by nuking the thing or something, it doesn't work. It just doesn't work. You just wind up with a whole bunch of nuclear material heading toward your mainland, and it didn't do anything to the hurricane at all because it's just so powerful. Yeah.
There's also some out there theories about hurricanes as well, particularly in this politically charged climate we're in. Let's just say that there are some people that are exposing the theory that the CIA or some three-lettered organization is able to create a hurricane, and then not only this, it gets better. Not only create the hurricane, but steer it and then direct it directly onto Republican counties and pinpoint areas of Florida to hurt the Republicans. I'm like, who comes up with these ideas?
I
mean, no way.
There absolutely is no way. And if you just do this simple calculation with the physics and the math, it's clear that there's no way. No three-letter agency, no U.S. government, no government on Earth.
Like trying to stop a steamroller with
all of our nuclear weapons together. Exactly.
Hey, what's the initial spark that starts the hurricane? Like with your mind, just tell me that a little bit about that. The initial, what starts it? What does it?
A hurricane starts typically when you have a region, maybe hundreds of square miles across. Okay, big. In warm waters, say the southern part of the Gulf of Mexico or the Atlantic Ocean near Africa or Brazil. And all of that winds up just in a little low pressure system, like a little depression, something that here in mainland US might just create a little bit of rain. Okay, just a little bit of clouds. But what happens is when it's that warm, and it's across that large area, not any pinpoint, but it's got to be really big. What happens is that you wind up creating a funnel, and the funnel sends that warm, vaporized water upward in a channel, and then you create a circulation pattern, right? The circulation is caused by the Earth's rotation and the atmosphere's interaction.
Is that called the Coriolis effect?
Yes, precisely. Yeah. The Coriolis effect makes it so that the storms are always spinning in one direction when they're in the northern hemisphere, and they're spinning the other direction when they're in the southern hemisphere.
We said that on one of the other shows last week, and one of the guys in the chat room said, "No way, that's not true." And we're like, "Yeah, it really is true. You can go down there and test it yourself."
on small scales, sometimes people they're like fun sort of carnival tricks for people who live on the equator. You can pretend that like a bowl of water will do that kind of thing. Turns out that doesn't work so much because the Earth is so big. that you need large systems, much bigger than like a swimming pool in order to see any kind of Coriolis effect. But hurricanes are miles across. And we saw those satellite photos of both Helene and
it was larger than the entire state of Florida.
That's right. That's right. With things that size, the rotation of the Earth, the mechanical activity of the atmosphere and the water and the land spinning at different speeds and so forth creates these kinds of effects. And that's how you wind up seeding the hurricane, not with like one tiny thing, but like a big overall effect of large amounts of heat.
Nice. So what got you started with quantum physics? What was the catalyst for that? You're like, I'm going to be a quantum physicist when I grow up.
Oh, no, that's a great point. And the thing, what might surprise you to know, since I just wrote the handy quantum physics answer book, is that I'm not technically a quantum physics researcher. Okay. I don't actually do like heavy research into like the absolute details of stuff that's going on in there, but I use quantum physics every day. See, my research is in astronomy, right? I study distant galaxies that are crashing into one another, starburst activity, star formation history of the universe, supermassive black holes that live in galaxies, things like that. So I study very large things. But quantum physics is describing the physics or the science of activities on objects with tiny, tiny scales, things that are a millionth of an inch or so or less in size. And so it's a little bit counterintuitive, but it turns out I use quantum physics for everything that I do because everything cosmic, everything big is made up of huge numbers of tiny things, right? We humans, the planet, we're made up of not just trillions of tiny particles, but we're made up of trillions of tiny particles.
Yeah.
And so every single little interaction adds up eventually to create the things that we see in our daily lives. And so about 100 years ago, when people were first understanding and starting to get down to atoms and molecules and confirming the existence of electrons and things like that, they were starting to understand how little tiny things aggregated in their trillions upon trillions will wind up creating the huge, gigantic, or even ordinary phenomena that we have today. So that's how I became involved in wanting to do this quantum physics book. It was from doing other physics like astronomy and astrophysics that made me realize that everything that I was doing had some sort of quantum component at its core. And I wanted to tell that story for people who were like wondering, boy, what is this weird, strange quantum physics stuff? And say, you know what? It's not that weird at all. It's just following different rules from what we're used to in the non-quantum environment. But if you look at it carefully, you can apply it. And bingo, we wind up getting great things in our own lives today and understanding everything from how cell phones work to how lasers work to how black holes work, if we know a little bit about quantum physics. So that's what the book is about. It's for people who aren't specialists, but people who kind of want to know how to use it and what to learn from it, and how it fits into our everyday lives.
Definitely. And that would be me and lots of people. I try to do it like this show, for instance, is because when I was 17, I went through testicular cancer and chemo, and I lost one and woke up from exploratory surgery to be told you lost one, you're going through chemo. And I'm fine now. Of course, I survived, and it was Emory University, and they did a great job. And then several years later, my father passed away. So for some reason, all of that weirdness brought on a lot of strange events, from seeing things that my interest in aliens was like E.T. at the drive-in. Like that's about it. But I've seen weird things in the sky with multiple witnesses and some different types of beings, like beings of light. And like I saw 2 beings of light down here in Florida, like they had been in my home and left and flew into the heavens from my house, and just strange things. And it turned into me. I've had Stanton Friedman on a long time ago. That's how long I've been doing this. I know he was brought up quantum physics and stuff and was a big UFO researcher, Stanton Friedman. Jim Mars was another big one that he also did that Oliver Stone, JFK, the book that inspired that. And he did an alien book. So I would interview these people to try to figure out, what the hell was I seeing? Because I still really don't know. I've interviewed lots of people, but I don't have I just say I don't know a lot. But I like quantum physics, and I'm definitely no expert, but to apply it to that somehow, that these multidimensional realms and things like that. So I'm always trying to apply it that way. So your book helps a lot for someone like me that's a beginner to even try to go there at all with my brain. And and that's and another thing that we've had Ron Moorhead on, who's had he's a well-known Bigfoot personality researcher, and he wrote a book called Quantum Bigfoot, and he basically it's a great book, and he basically breaks down some of the abilities that these beings, they seem like they have chameleon kind of stuff where they can blend and stuff, but he applies quantum physics to it on a level that's just like in your face, here you go, on a big level. But that's so there's people that are talking about the connection a lot, so I'm curious what you think about that, and I'd love to get into that some, like the multidimensional realms and some of this weird stuff that happens.
Sure. Happy to get into that, some of that. It's really interesting when you get to the quantum level, because these quantum effects, as we understand them scientifically, happen over tiny distances, right? These objects, like I said, these particles and fields are like a millionth of an inch across or smaller. And so in order for them to affect anything at any distance is almost impossible unless you keep something called quantum coherence going on, right? So what's happening is not so much, and people have looked and trying to find that kind of quantum coherence, and have done pretty good jobs on sort of very basic experimental levels. But on the levels of the amounts of energy required to move human beings or spaceships or things like that, just straight up quantum activities don't quite work quite right. And they don't add up in terms of the amounts of energy necessary to have happen. And so we are looking at a different way of thinking about quantum physics in that direction. Now, this is, I don't want this to sound too sort of unrealistic, but it gets into philosophy. People who are doing quantum physics often wonder, what is reality? And this is where we get into the idea of quantum stuff happening in our minds and in our bodies, which might actually be the filters for reality for each one of us. In other words, is it we humans that create the reality in which we live because of the processes that go on in our own minds and consciousnesses, as opposed to actually quantum physics influencing the universe at a distance when it otherwise can't? So I found that to be very interesting right now, because it's getting into the philosophy of what is reality. And so what quantum right now is doing is trying to understand the little things that are going on in perception, in the way that our brains process information. We know that, and we can talk about this in a minute, about multiple universes, what we call multiverses, right? The many worlds interpretation of quantum physics and things like that. The idea that there are many realities that can exist or could exist, but there's one reality that we all share. And therefore, that reality, on an objective point of view, is actually perceived differently by each one of us. And we all see a different piece of that shared reality because of the filters that our brains and our consciousnesses provide on the reality that we observe.
That would mean everyone on the planet is telepathic then.
Well, it's not so much telepathy, but it's so much like what we are shared experiencing. Does that make sense? So here's one way we can go about this. We'll talk about the quantum physics of vision. Okay, the way you and I see with our eyes is that light comes into our eyes both as a wave and a particle. That's the duality of particles in quantum physics, right? Now, what happens is when it reaches our eyes and our retinas and in our eyes, they hit rod and cone cells. And so there's a quantum reaction between the photons, the pieces of light that hit our rod and cone cells. And that interaction turns that light information into electrical impulses. The electrical impulses then go through our nervous systems and then into our brains, where then we process it. And so what happens is that if you and I, the three of us, were all looking, and the cat too. We should talk about Schrodinger's cat. I would love to do that at some point. If we were all looking at the same light source, some light bulb, okay, each one of us sees the light that's coming from this object, but our brains process them ever so slightly. And as a result, we're not so much telepathic, but that we are communicating between the three of us through our speech and through our conversation, the ways that our eyes and our brains indirectly have processed this information from our shared universe.
Wow. Yeah, wow. It's an interesting thing, but it also kind of seems like a sort of telepathy, like you're projecting what your reality is, my reality. I'm projecting that, and you're seeing what I'm projecting. That also sounds like telepathy.
Yeah, when we have tried to use scientific instruments and so forth to measure to see if there is actually like brain to brain communication, right? It turns out that there is brain to brain communication as long as there's like voice that goes through or touch or things like that. If we're just not interacting in the physical world in some way, then the ability to communicate with each other with this sort of telepathic thing has not yet been seen. So that's a frontier of physics that, despite all experimentation and measurements and so forth, has not been shown to actually happen. That said, it is true that we communicate in very subtle ways. Many of us are communicating and talking with one another in ways that are sometimes highly nonverbal. Or if I know you well, if we're friends and we've known each other a long time, I sometimes can predict what you're going to do because the inputs that we've shared over the years, right, have
based
sort of
on previous behavior,
have shaped our perception of the world and our reactions to the world. So in many ways, it's not so much that you've communicated with me in some unusual way now between about what you were thinking and what you were doing, but that actually we had communicated enough in the past that we were able to get that information out. It's very subtle and very fascinating, but it's really neat because our brains are so complicated. You know that like the average human brain has more synapses and more neurons in its connections than the internet has computers, right?
Wow.
And so nowadays we're using ChatGPT or some AI systems, and we're like amazed at how complicated and how it's able to do something so fast and so forth. Well, every one of our human brains is physically and chemically more complicated than the entire internet.
Yeah, that's very true. Also about our eyes that you were just talking about.
That's right.
I have a degree in video with a minor in photography, still photography.
Excellent.
So I actually have developed my own film,
Wow.
black and white, not color.
I love
that. I'm no Ansel Adams, but I took some pretty good pictures.
Nice.
And thank you. And I passed all the classes with passing grades, and I enjoyed it. But the teacher said, and then it's very true, that no camera, and it's still true today with the digital cameras, no camera is able to take a picture that our eyes can see that is better than what our eyes can see.
Yeah.
And it's true. Every time you take a picture of them, even if it's your best picture, you go, hey, you show it to your friends, you go, doesn't bear any resemblance, but here you go, take a look, right? Every time you present a picture, you say almost the same thing because they don't. Our eyes just are complicated devices that, like you said, they're getting hit with, as you said, we have a different perception, slightly different perception of reality. We're getting hit from light and particles, but the particles that are hitting me aren't hitting you.
Right.
Or Jeff. So that makes sense that because there are different particles getting into each of our eyes.
So we are sampling our shared physical space, our physical reality differently, right? And as with any kind of statistical sampling, we're going to get something slightly different from one another. And so when we have our different experiences and we're trying to commonalize them or make them more in common, in sync with one another, we have the other kinds of communications like speech, and photographs and things like that, right? That wind up allowing us to become more aligned in the things that we see and experience, and that's cool. And then once it gets into our brains with that wonderful, complicated wetware and the software and the hardware that's going on in there, anything goes. Really, anything goes. Yeah.
So when you see a lot of this modern UFO stuff, what's your reaction to some of it? It's complicated because most of the time you're like, it's probably not an alien, it's probably our own government. But there are people that have seen strange things, and shamans and stuff see strange things, and natives have talked about these things, forever. And it's strange when you, like, for instance, our government 1 minute is having hearings about it that are really weird and creepy on a lot of different levels. And then another part is of the Pentagon's releasing videos. And then the next thing you know, the Pentagon's saying there is no like aliens, but they're still having these weird meetings about UFOs and aliens being taken. So you're like, what the hell's happening? It's like, what is going on? Like, it's just confusing.
Well, here's my take on that. If this is worth anything, I mean, it's just one person's experience, right? Yeah. I have worked at NASA. I have been involved in various kinds of research that have been funded by government agencies and organizations and things like that. I have many friends that have done that kind of thing for a long period of time. And I got to tell you, those organizations aren't all that. They're made up of human beings just like you and me. They're fallible. They are opinionated. They do a lot of neat things. They have a lot of cool toys. But in the end, they're not some, powerful superhuman cabal that can change things like, create hurricanes and move weather systems and things like that. Right? It's just not my experience, right? And I have seen enough. Of course, I haven't seen everything, but I've seen enough of how the federal government works on the sci-tech side of things, on the aerospace side, on this, that kind of side of things. But just really think that those kinds of ideas that they can do superhuman, supernatural things or that sort of stuff is just, it's fun to think about, but it's just not reasonable and possible. So what I have heard are individual things that can be actually a lot of fun and a lot of reality bending stuff for our own minds, which are fun to think about, but put in their context, they make sense. I'll tell this particular example. A friend of a friend was working for the U.S. Air Force. Okay, this is 30 years ago something. So if I don't remember the exact details, forgive me on that. No problem. This guy was a mechanic for the Air Force, and he was working in what we today know as Area 51. Okay, they were at that time working on the first stealth fighters and stealth helicopters and things like that, right? And it was always in their best interest to keep everything quiet and not actually do stuff, but they would get just enough information out to get people's imaginations going. And that actually helped them keep their materials actual secret. So the things that they actually could know and needed to keep secret from the Russians or the Chinese, right? They could actually do a better job of like smoke screening their stuff. This guy said that there was one particular pair of these stealth helicopter pilots who loved to go out into the desert, right? This is California and Nevada, so kind of now down near Death Valley, and just, there's like literally like one single dark desert highway, right? And there's a guy coming down that road, maybe in his pickup truck, and these guys, just for fun, would match course and speed in their stealth helicopters in the middle of the night, and then just turn on one light and aim it at the steering wheel of this truck. And so this guy would sit there and they would like have their cameras on. They'd be laughing their heads off in the helicopters. And they're just laughing while this poor driver is like, whoa, where'd that light come from? What is this? What is that? Right? So individuals, I do believe, will mess with us. Right? Higher systems of people, like some alphabet agency or Department of Defense or something like that, they're less likely to mess with us. But individually, those stories can propagate and turn into this sort of.
They're actually true now. Even like not no longer top secret. The new F-22, which has been out for a while, allegedly, and apparently is true now, it has a system that makes it actually invisible to the human eye.
Wow.
So yeah. So what they've been doing was they've been following some of the Russian fighter planes, and this is just recently, and we've reported on Joe's show several times. They're following the Russian fighter pilots and listening to their conversation, and also these American fighter pilots are also able to understand Russian. And when they find out what the Russian guys are talking about, they uncloaked themselves right in between them, and they said, "Hey guys, I don't think you want to do what you're doing," in Russian.
Wow.
The two Russian pilots see them and bugged out of the area immediately.
Wow.
Because they didn't have no idea that he had been there and following them, and he just turned his cloaker off and boom.
Yeah,
So,
that may well be true. I don't have any information on that technology, but
according to Joe,
totally,
he said it's true.
yeah, it totally makes sense. Yeah, it totally makes sense that individuals, like I said, will use that technology in these ways, right? We now are able to spoof any camera, right? If we have the proper security protocols and so forth, we can spoof any sensor. We can fake out any computer to display what it thinks it's seeing, and it's not secret at all. It's not any kind of non or strange or fake science or anything like that. This is actually straight up technology and science and wireless communications and things like that. So for the opportunities, whether they do it on purpose or whether something happens by accident and you wind up recording on a camera or with your eyes, you see something, some sort of an effect which cannot be explained physically by something that's like flying or otherwise being propelled with an engine. I would not be at all surprised that some of, if not almost all of those kinds of detections are indeed these kinds of spurious things that exist in our technology but aren't really talked about.
And one of the weirdest things that's going on right now, and I want to tie this question into your book on some level. Yeah. I don't know if you've kept up with any of the Skinwalker Ranch stuff at all, but there's the show Secret of Skinwalker Ranch, and then there's the show Beyond Skinwalker Ranch. And basically it ties into Robert Bigelow owning that ranch in the past, the aerospace, dude. And then it has a lot of phenomenon happening there. But the weirdest thing about that show is there's a lot of government agents on it. Like there's former CIA, there's former Bigelow personnel that used to work there. There's a former scientist, Travis, I forget his last name, that worked for Bigelow at the ranch, and then Bigelow sold it to Brandon Fugel. There's just so much weird government stuff. It's creepier than the paranormal phenomenon that's happening on the show. They actually had a guy, Chris Bledsoe, on there with neurology equipment on Beyond Skinwalker Ranch, and he can summon UFO light phenomenon. And he had two former CIA with him on the show, and Colonel John Alexander. So that's how weird that show is getting. Like they're using it for something. But the thing is, my question is, on Skinwalker Ranch, there's a lot of weird radiation situations where people are getting burnt and having to go to the hospital, and they could possibly die, like weird stuff that they're being attacked somehow. And I know there's legit phenomenon happening there, and it's a different show compared to other shows that are about paranormal. This is a lot weirder, and something they're using this for some kind of something that ties into all these powerful figures. But it's weird. But with radiation and stuff, I mean, if you were at a place that was a ranch and then suddenly someone got doused with radiation and a radiation spike happened, how would you approach that? What would you think that was coming from? I guess it's kind of the mystery there. Like there's radiation attacking people on the show. It's really weird.
Well, those are great questions. If I were to think on it from a quantum physics point of view, I think of two possibilities. One is that we have now developed technology, and some of it is military, but a lot of it is not. It's civilian sort of research stuff, where we can beam radiation that's not very high energy, but in concentrated shots, right? Now, lasers, of course, are a modern day phenomenon. Everybody knows them, whether it's a barcode scanner at your supermarket or inside
Cats
abuse
love
of
them.
fire. Yeah, cats love them. They're everywhere, right? But lasers are carefully regulated so that they're not super powerful and can cause issues and damage, right? But it is possible to have a device that might be the size of a pickup truck that can create a beam of energy that isn't going to vaporize you or turn you into dust immediately or anything like that, like a death ray, nothing like that. But it can cause great discomfort and it could cause burns. And so if there were that technology being tested or being abused or something like that, you could imagine people being burnt and hurt by that. Now, there are some law enforcement agencies around the world, I think in Europe mostly, but in other places as well, where they're testing these kinds of beamed weapons, not so much as to be able to kill or injure anybody, but to cause great discomfort in a very short period of time. And this is infrared radiation, right? So it's not going to hurt you if it's not concentrated, but it just sort of, if it hits you the skin, it's like being poked with a sharp knife or something like that. Now it's not going to hurt you again, but it hurts. It's not going to actually injure you, and that will disperse crowds, or that might cause individuals to be disabled temporarily. And that
Yeah,
technology is being tested.
they use sound in the same way, certain sound frequencies that you can't
That's right.
really hear with your ear, but you just all of a sudden
That's
you're
right.
like, "Whoa," and you just lose it. Yeah.
Well, have you heard of this illness that many American diplomats were experiencing during
Yes.
the past decade or so. Yeah, in Cuba and a few other places, these were folks who were otherwise perfectly healthy, and then suddenly they were developing hearing loss. They were developing headaches, things like that. And the hypothesis was possibly that the governments of Russia and maybe Cuba or other places, North Korea, were actually harassing them with these beams of radiation, sound waves at high pitches, maybe microwaves, things again that aren't going to injure you, but things that can over a long period of time be as damaging as like
Yeah.
concussive blasts. If you were like running artillery shells or something like that, or just being sort of overexposed over long periods of time. So that is, if there is a human technology involved with that, there is some quantum involved in being able to beam these weapons in such a way, right? Lasers have these resonance cavities, and they have to have the stimulated emission so that you put in a certain amount of radiation in one direction, and then you get out much more radiation of the same wavelength and frequency, right? Same energy, but you put in other energy. So you're not getting something for nothing, but you wind up focusing what you have into beams like that. So that's one possibility I can think of. Another
There's definitely people being attacked there. They brought in the guy that was some of the witnesses of that TikTok video from the Tic Tac video from the UFO Pentagon videos. They brought some of those soldier dudes in, and they got sick and had to leave. A lot of people get sick and have to leave.
Wow.
It's a weird show. It's definitely weird.
Yeah, the possibility exists if there are people using these kinds of or testing these kinds of weapons. I couldn't vouch for that. I don't know about that kind of work.
It's interesting.
Yeah. Now the other side about people being burned and people having to go to the hospital, is there nuclear waste in that region? Do you know?
There is some speculation that possibly they might
Yeah.
be, but the U.S. government says there weren't any tests in that area, and that they said there aren't any burials of like waste or secondhand material that would be harmful.
Well, I hope that that's true, because it is true that
Be a
nuclear
lie,
waste,
yeah.
nuclear waste
Be a
is
lot.
a
Yeah, I mean,
problem in
that's
our
the
country.
thing is the government,
Or
but
it could even be that, the government is telling the truth and that people who are non-governmental have this material, right?
Yeah,
Unfortunately,
something's interfering with their technology. Any kind of technology, they have crazy technology, but something's always interfering and messing up the technology, like messing it up.
it may well be true. Unfortunately, our nuclear stockpiles are pretty well protected in America, but not so much around the world.
yeah,
And if you have a nuclear power plant like the Europeans, the Russians, Ukraine, of course, there's a very big one operating right now in a place called Zaporizhia. But Ukraine was where there was a massive release of radioactive material from Chernobyl in 1986, right? And that material was enough to irradiate millions of people, right, in Ukraine, modern day Belarus, and even into Finland and Sweden and Poland. And so that kind of thing, unfortunately, can happen. I can imagine some, people that we don't like very much, or people who are trying to be very secretive for whatever reason, if they got a hold of some sort of toxic waste, or even, God forbid, that kind of nuclear waste, that stuff really has to be stored carefully. And if they somehow are not being taken care of, and if it's there, then I have no idea what the consequences could be, but they could certainly be severe, especially for individuals.
Yeah. I always get paranoid that a nuke can like obliterate your soul to where you're like your spirit's gone. You're like, man, that would suck. A nuke already sucks, but it's gonna like eat your soul too.
Wow. We, in astronomy, when we're talking about nuclear technology, we think of it as any kind of technology. It can be used for positive or negative purposes. Right. Anything is like that. Even our cars. I often tell this to my students, when we're talking about technology, because they'll often ask me, like, is it right or smart to use nuclear power? Is it smart to use these kinds of technologies? Right. And AI, for example. And I tell them, look, if you're driving a car, you wouldn't start the car, rev it up, and then walk out of the car and let it go wherever the heck it wants. Right.
Yeah.
This is a thing that's going to cause problems. Even if you had a driverless car AI technology that could get it from street to street, you wouldn't just.
Well, you pose an interesting problem, though. I mean, think about it. When/if it's more a question of when rather than if that we do get the self-driving cars. Some knucklehead's going to go, take me home, and then watch his car. And he's like, oh shit, I forgot to get in the car.
Yep.
That's going to happen. There's going to have to put in some kind of safeguard.
That's right. And this is the deal, right? It's exactly the same deal as you would with any kind of technology, including nuclear power, including AI, including regular cars, right? Why do we have seatbelts in cars? Why do we have bumpers in cars? Why are gas tanks made so that they don't explode if they get hit? Right? These things are all built in as a form of safety precaution so that we humans can use this technology for positive reasons and not just get zapped by the negative reasons out of carelessness. The same is true for quantum. The same is true for nuclear. The same is true for AI. If we're going to use AI, for example, there's a whole branch of computer science called AI safety, where they're trying to say, hey, how do we make sure that AI keeps its activities within the way that we want to? It just like any other technology, you don't just let it go, right? You don't just hand a vat of nuclear waste to a 7-year-old and say, here, have fun, right? We have to be very careful of whatever consequences we decide to use. That's sort of my opinion.
And I know you want to talk about Schrodinger's cat.
Yeah. Where is that kitty? Very sweet kitty there.
I'm trying to catch her.
All right.
I have 4 or 5 here, 4 here. I lose count.
Really? Oh, that's wonderful. Hey there. Hi there, kitty.
She's just a baby. We picked her up this morning.
Oh, how sweet. The cats are cool because they're just cute and sweet and friendly, and they just do whatever they want. And we don't really have a whole lot of say in that. But one of the things that Erwin Schrödinger in the early part of the 20th century, basically was saying was, we can use a cat as a way to think about this thing called uncertainty and this thing called duality, okay, or even more technically, something called superposition. All right. He said the following, and this was sort of half jokingly originally talked about in correspondence between Erwin Schrödinger and Albert Einstein about the nature of quantum science and quantum physics. He said, we know that there's a quantum effects, but we don't know exactly when they're always going to happen. We have a probabilistic idea. So if you have an ounce of plutonium, you don't always know exactly which plutonium atom is going to decay. There's only have a chance at any given time that any particular atom will decay. But you know that if you give enough time, over a certain number of thousands of years, then this 1 gram will become half a gram, and all other subatomic particles and different kinds of other elements as a result, right? It's a sort of a systematic, but a statistical kind of measurement, because you're talking about trillions upon trillions of individual particles. Well, you said, well, what if we imagine an experiment where we put a cat in a box, and that box is not transparent, So you cannot tell what's inside the box. But inside the box, there is a device that would be triggered if a particular atomic or quantum process were to happen. Okay, at any given moment, there's a chance that it'll happen, but there's also a chance that it won't happen. If the event happens, then something causes the cat to die. Okay, a poison capsule opens, for example, or something. The poor kitty, dies. If it doesn't happen, then this kitty is safe and it is not harmed. Okay, and so he said, while the box is closed, you do not know whether or not this quantum process occurred. So you do not know whether the cat is alive or dead, right? Let's say you knew, though, that this quantum process has a 60% chance of not happening at any given moment and a 40% chance of happening at any given moment. So while the box is closed, is it fair to say that the cat is 60% alive and 40% not alive? Or do you have to say, no, it's either alive or not alive, and I just never know? So that's the Schrodinger cat problem. Once you open the box, then you can tell, this thing happened or did not happen. But while the box is closed, it is mathematically appropriate to say that Schrodinger's cat is 60% alive. So the alive wave function is up here, and 40% not alive. So the not alive wave function is down here. They are superposed one on top of the other. So the cat is alive and dead at the same time. Now, obviously, it's not, but mathematically, you can treat it that way.
Wow. It's cheating, though.
Kind of. And it led to that whole idea of how quantum physics actually works. And this led to the many worlds interpretation of quantum mechanics, right, which we were talking about earlier. And the idea is that for every moment that atomic process doesn't happen, right, that object or that cat is still alive. And if you keep watching it, if it does happen, then the cat perishes. But while it doesn't happen, and every second that it doesn't happen, the universe continues to go forward as if it were not. So you're basically, with every fraction of a second, with every possible quantum process happening, you're bifurcating time streams. And so in this universe, the cat's still alive. It's that one, it's still alive. That one's still alive, but this one it's not, and this one it's not. And so you're creating a mathematically equivalent single universe of a huge number, maybe not infinite, but certainly huge number of parallel universes, creating one single multiverse. They're all mathematically possible, but the one that we live in is a single one, and we can't access those others. We just know that they could exist, which is really quite amazing.
I know you have a little section on the end of the universe. Do you think that's really the end of the universe is really going to happen? And what would that be like?
Oh, great question. Okay. The definition of end, right, is at play here, right? Because what is the end, right? You and I.
Really good song by the Doors.
There you go. It was also like not a very good movie starring Burt Reynolds or something in the 70s.
Yeah, I mean,
yeah. Well, when we think of us humans coming to an end, we usually think of like we stop breathing, our hearts stop beating, something like that, right? But when you think about other things coming to an end don't necessarily mean that everything stops, right? When a star, for example, like our sun, comes to an end, it will end by ceasing its nuclear fusion. There will be no more nuclear fusion, and therefore you could say the sun is done, right? It's dead. But there is this white dwarf that's left over. There is a planetary nebula that's left over. And those things carry on and they continue to exist. And in fact, that white dwarf, which is about the size of the Earth, but it weighs more than 100,000 times that of the Earth, that thing can last for trillions more years, maybe even more than trillions of years. And if in its travels around the galaxy, another white dwarf comes nearby, or another star comes nearby, or cloud of gas is nearby, it can literally come back to life. It can merge with other objects or combine or add material from other objects, and it will start shining again. Not exactly the same way as it did the first time, but differently. But it's still producing new energy that it otherwise you thought, well, was just sitting there doing nothing. It's just a cinder, but actually it's still going on. It's just in a different form. So if we think that way, sort of astrophysically or quantum physically, the end of the universe can be thought of as a time when everything that we are familiar with that keeps time no longer exists. Does that make sense? Right now, we keep time with clocks, with Earth going around the sun, with the universe expanding, things like that, right? But there's always something that's sort of changing, right? Something that's continuing to progress in the universe. And as a result, we can be confident that whatever was going on earlier is different from what's going on now. But if the universe continues to expand without stopping, as we think the current structure of the universe and our measurements suggest, what will happen is that all of the stars will stop burning, or more precisely, stop conducting nuclear fusion. Eventually, you'll just have these remnants, white dwarfs, neutron stars, black holes, things like that. And they just start drifting, continuing farther and farther and farther apart. So the universe gets more and more empty. It gets colder and colder. And then, if what we're really right now, our hypotheses and our measurements aren't able to get us where we need to be on this, but if we think that what we know about quantum physics is true, protons, those things that make up the atomic nuclei in our bodies and so forth, protons will decay. They eventually, this is like a trillion, trillion, trillion years from now. Okay, protons may start to decay to the point where atoms can't hold together anymore. And so even white dwarfs, the cinders of stars, whatever, they will also dissipate and disintegrate. And then all you have left are black holes. All right. Now, black holes aren't anything weird, right? Again, they are a piece of the universe where inside a certain limit called the event horizon, we can't see and we can't detect what's inside, but it doesn't mean that it has to be not. It's just a material. Those black holes, they are slowly decaying also. Their matter is being converted into energy at an incredibly slow rate. So if you wait long enough, right now, current estimates are something like a trillion, 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 trillion years. Okay, so right now, remember, the universe is only 13 billion years or so old. So we're not even remotely close to this distance, right? At that time, even black holes will have disintegrated, and all the rest of the matter has disintegrated. And so you wind up with this universe that has no real way of gathering energy again, of changing processes. You wind up with this really, really cold, almost at absolute zero universe, and a lot of these particles that are zipping around but unable to organize. So at that point, we could say that the universe has come to an end.
Well, there is some speculation. I don't know if you can speak onto this subject matter, but there is some speculation that a black hole is merely like the entrance, like a drain. And I don't know. I don't think it's a white dwarf, but what is it on the other side?
Probably a white hole is what you're thinking of.
Oh, a white hole, but I think that also there's a phenomenon out there that I can't remember the name of it, that they think that's what the other end of the black hole is. So what if that is the case? What does that entail?
Great question. Right now, if you do the math, right? Remember, the math is always more complicated than the reality, right? And when Albert Einstein put together Einstein's field equations, there are a huge number of possible solutions to them. But right now, there's only one that sort of reflects our reality as we see it. But mathematically, it is possible within that one universe that we see to have these tunnels through space-time, right? Things that you would, for example, call a wormhole. If these things exist, then we should be able to see them. We have enough telescopic power. We can see the black holes. We should also be able to see the white holes. And up to this point, we have seen no objects that match black holes as a white hole. And so right now, that model,
still a
that
theory.
hypothesis is, yes, it has not been confirmed. So it is, at the moment, we can't say that that's real. But mathematically, it's still possible that it exists. Now, I read something about 2-3 months ago, which takes this a little bit further and says, you know what? Even though we may not be able to see wormholes coming out into the universe for us to see, there is a small mathematical possibility that you could send a wormhole from inside one black hole and outward into another black hole. So could you have these black holes, which are perfectly normal objects, like I said, in the universe, but we can't see what's inside them? Imagine if you had wormholes going from one black hole to another in the universe. Mathematically, it's possible. Unfortunately, we have no way of measuring and figuring out whether that's even remotely possible.
Yeah.
It's cool though, right? It's fun to think
about. There are so many cool theories out there. One of the ones we like to talk about a lot is the Dyson sphere, which I don't know if that was a real thing. I looked it up on Wikipedia, which, okay, it's not, it's like it's not the Britannica, but it's available and it's free.
Mm-hmm. Yeah.
So it's a unique sphere, and recently there are, I think the number is 8 or 9 exosolar systems that we've detected with the James Webb telescope that apparently have structures around the main star of the sequence. So what does that? I mean, the idea in Star Trek: Next Generation was there was a sphere, a metal ball,
yes,
around the sun and out like 3 solar atmospheres, like where Earth was where the ball stopped.
That's right. That was the Next Generation episode where Scotty showed up. That was called Relics.
Yes, where you see Montgomery Scott.
It was a fun episode. Yes.
Yeah, they bring him into that. They bring him 100 years into the future, or 78 years of.
Yeah, anyway, he locks himself into a transporter code, which is really quite remarkable.
Yeah, he's the genius of engineering. But the idea is that they harness the 100% of the sun.
That's
and
right.
They, instead of the planets now, when they're inside the ball.
That's right.
The ground is on the inside of the ball.
Yes.
But the structures that seem to be around these stars, some are like have holes. Like you can see like the structure and then the sun through the structure. Can you speak about that? Have you read any of those articles?
I have. And first I'll talk about the fact that these Dyson spheres are in fact imaginary at the moment. They were imagined by a guy named Freeman Dyson, which in fact, even before Freeman Dyson became popularly associated with these spheres, there was a science fiction writer named Larry Niven who wrote a book called Ringworld. Remember that?
Yes.
Ringworld, and then the sequel called The Ringworld Engineers. And he imagined a civilization so advanced that they could create a huge space station that was 93 million miles in radius, and it would circle around like our sun, and you could live on the inside of it as if it were this amazingly huge donut-shaped planet, right?
Yeah.
And so these ideas have been around for a long time, and we really need to be able to see them. One of the consequences, if they were to exist, is that a star would in fact occasionally fade in and out, or they would have different amounts of light coming in, depending on whether or not you were looking at it at the angle where the ring was or elsewhere, right? The way that we human beings nowadays are looking for planets outside our solar system, just as you had said, exoplanets, right, is to look and see if, one of the ways to do it anyway, is to see if the light amount from the star changes, right? If a planet is passing in front of and then behind a star, then that planet will cause the star's light to temporarily glow dimmer.
Shift from reds to blues and whatnot. And the deeper the shift, the more planets. And
precisely. Yes, exactly. The current ideas that, for example, the JWST and other projects are seeing with these kinds of light changes and so forth, they could be explained by the existence of something like a partial Dyson sphere or a multiple ring world or something like that. But it is much more likely that they are explained by dust and interstellar dust or even interplanetary dust. is set up in certain patterns.
Nebulas, other dark, backdrop. It's going through things that are blocking out parts of the spectrum. Yeah.
Yes. For example, our solar system has a whole bunch of dust in it. Okay.
Mm-hmm.
If you add up all the dust, it's still much less mass than like the moon. Okay. But because they're tiny particles and they're spread out over a long distance, if we were, say, outside our solar system, like send a spacecraft really, really far away, like even farther than the Voyager spacecraft, and looked back on our solar system, depending on what angle we looked at, we would see a different spectrum of blue and red light, or different kind of motion patterns because of the dust. And there are ways where we can model the distribution of dust around stars outside our solar system that can set up things that would look just like, or even more amazing and stranger even than what would happen if such a thing like a Dyson sphere or a ring world were to exist around the solar system, or in a planet around a star. So right now there is no need to invoke those kinds of structures to explain these objects, although it's kind of neat to think about, right?
It's a cool concept. Joe was talking about one that he read an article on where they had taken several, I don't know over what the time span was, but so many photos of this one particular star that the star wasn't obscured, then it was, then it was more obscured, and then it was more obscured, and it seemed like there was construction going on. Like there was, phase one was complete, and then next year phase two started being built, and then finally that there was like it in the article that Joe read, it seemed that after whatever the time span was, that it was now finally totally encased, and now that star is gone.
Right.
So whatever
you can speculate that way, and it's kind of fun. The likely explanation, though, is not that, because to construct something like that would not just take a few days or weeks or months or even years, right? It would take centuries,
eons, maybe
millennia, right? Because imagine even for us building a skyscraper or an aircraft carrier, it takes years, right?
Oh yeah,
imagine building something that's thousands of times larger than even the entire planet Earth, right? It wouldn't happen overnight, that's for sure. So
there are certain things that you would expect to, be built on a certain, faster time frame. I mean, obviously, when we build buildings, it takes, I don't know, for building a house, for an example, is a simple process. Some companies can do it in like, a day with some of these modular homes,
pieces, right?
Prefabs. A stick-built home, with the stick-built frames and whatnot, if they do it right, 4 months. They can do it right in 4 months, okay? Because I've seen it done on this old house.
Right. Yeah, I know exactly what you mean.
Right. So, however, there are certain things like the pyramids. They say were built in 22 years, and I'm thinking if whoever built it was very advanced. It wasn't humans and it wasn't the Egyptians. They just didn't have the technology.
Let me stop you there. And I will say, indeed, Chariots of the Gods is a compelling read. It's fun to read and things like that. But what actually we have found, and some people have done this experiments over time, is that our ancient ancestors from the ancient Egyptians and so forth were really very clever. In fact, the technology to build the pyramids, and not just the Egyptian pyramids, but like the pyramids in Mayan cultures, right? Chichen Itza and places like that. Those are actually well within the technological capabilities of those ancient civilizations. It was not that hard, in fact, to do those things. What they did was they were willing to throw thousands and thousands of human lives at it. So unlike us, where we're like, we got a construction crew, we want to give them a good wage, build the house, and go home for dinner every night, and raise a family and stuff. They were willing to just throw hundreds, thousands of workers and just work them till they died, and to build these ridiculous monuments. And so as long as they had enough people and enough time, they had the technology to build things like the pyramids. And that's kind of really interesting for me to know, to think that a lot of things that we ascribe to technologies or to skills that are beyond us, turns out, our ancestors were pretty clever. And that makes me feel good, right? Because we humans actually are able to build some of these remarkable things which stand the test of time after thousands of years.
Yeah, I still don't think the Egyptians did it physically because and you spoken a lot about measurements. The measurements they've taken of this building, particularly Chris Dunn's work. First of all, to align the building the way it is aligned, we're talking about the big pyramid, Khufu's pyramid. Khufu, it's an 8-sided pyramid. The walls actually do like this number. They're not flat. They actually bend in, and this inward pointing arrow, those 4 points around the building, are all aligned to the cardinal points on the the
north, south, east, and west.
The compass. Thank you. But within a very, very precise, I mean, they're only off by like 0.000025. I mean, really, really, on there. And the reason why they're off is because the planet somehow has been misaligned through spatial stuff, what have you, because we spin off axis. You need the compass to do that. The Egyptians of the fourth pyramid did not have compasses. And I've studied this because I looked back in the history, because when I was in college, that was one of the things I absolutely looked at.
That's right.
They did not have the wheel, and you would absolutely need to have the wheel in order to transport the rocks they used, which came from at least 60 miles away.
So turns out, right, but that was the point.
But it turns out that they've recently found the Nile actually right in front of us. So it's possible they could have transported the rocks by river to the site.
Right, that's what I read.
But they also would have needed, in order to move those rocks either onto a barge and off the barge and to the job site, they would need the fulcrum, which is also sort of part of the wheel, which they also did not have. They didn't have the wheel until another 1,000 years later, when they got the chariots, and they became a very, powerful force.
Yeah, powerful.
So somebody built them. I mean, maybe humans, it may have been aliens, maybe been humans and aliens. We don't know who. But the tools that were built are either way lost, and in order to build that, you need plans.
Yes.
The Egyptians never had any plans. They have the pyramid texts or the pyramid scrolls, I forget which one, which talks about the material used to make the limestone cover stones. Nothing about the inside.
It is my hypothesis that material is lost, destroyed by the desert, or
when the Library of Alexandria went up, maybe that's where those tools and technology.
I really believe that. Yeah, to me, I would rather, from my scientific point of view, credit the ingenuity and the willingness to work of our ancestors to create these great things. I know, for example, mathematically, the Egyptians already knew how to make a perfect right triangle, right? Yeah. They measured out the 3, 4, 5 triangle, which we all learned the Pythagorean theorem, right? A squared plus B squared equals C squared. By experimentation or whatever, they figured out that a 3, 4, 5 triangle was exactly a right angle. And that's why their angles were so precise. We also know that the ancient, not just Egyptians, but Babylonians, or even many of the other Stone Age, Neolithic civilizations, they didn't have a television to watch or anything at night. They just watched the stars in the sky. And their astronomy was spectacular. Their astronomy is probably better than my astronomy is today, even with my computer apps that tell me where things are, because they paid so much attention to them.
Yeah,
so
there's a great Sumerian find. They almost all of their observations are they don't survive because they're made on little clay discs, basically like clay plates. I mean, they're no thicker than a regular typical plate. And they bake them and then they become brittle. But there's one that they found, it's Sumerian, and I don't remember what year it was from, but they were at least 5,000 BC.
Wow.
So the Sumerian culture is at least that old. So this observational star observational disk followed a meteorite that came across Europe. And then made a distinctive right angle turn towards North Africa, and then slammed into the desert somewhere where they suspect Sodom, Gomorrah, and Zoar were.
Oh, wow.
So there were three places that were destroyed by brimstone and fire. They found this disc that landed on 3 ancient biblical towns. They weren't called Sodom and Gomorrah. One of them was called Zoar, I believe, on this disc that they correlated it to. Which is fantastic. They may have observed when these hellacious biblical towns were destroyed by God when it wasn't actually God. And
but meteorites.
Right, boom.
Isn't that amazing? Yeah, I just am amazed. Archaeoastronomy is an area I know very little about, and it's really fun to read how people are trying to piece together that information from our ancient ancestors and really seeing how they really understood the sky and the stars
the stories are so pockmarked. We don't know the whole history of our past, and that bothers me.
So true. That's so true.
I think it bothers a lot of us. I mean, that's why some of us are scientists. I mean, I'm not a scientist, but I mean, in college and high school, my forte was the natural sciences and geology.
Well, Jay, you might not be a scientist by training or profession, but you have a scientific mind. You're asking questions. You're trying to figure things out, right? You're testing hypotheses. You're seeking evidence. Not just taking it on faith, whatever's happening, right? These are the kinds of things that for me is even more important than calling yourself a scientist. That inquiry, that idea, right? Albert Einstein said the same thing. Imagination is more important than knowledge when it comes to understanding the universe, because knowledge is just what you have now. Imagination and creativity and asking questions is stuff that's beyond what we know now. That's the best stuff. So bravo! Don't sell yourself short.
I'm doubly cursed. I went to art school and I love science, so I mean, I nerd out whenever I get to either do one of them.
I love art too, especially comic art and stuff like that. It's just great stuff.
Well, I didn't do comic art, but directly behind me, in the center there, is a Bob Ross style painting I did a few weeks ago. There's a nice lady up the road, the next town over, that's great. Classes. So
I also saw a stormtrooper helmet there, Jay.
There is a stormtrooper helmet. Underneath that is the Enterprise original model, and then
there it is.
The refit from the movies.
Oh, that's marvelous! They're
the big model. So when the disc is built, it's like 3 inches. Well, this is one of my lights. It's going to be about that big around, but just the top of it.
Yeah, fantastic!
Almost 3 feet long.
and I know we were talking about comics before we started.
Yeah,
and I've always when I went through chemo, I said a prayer to be a superhero. I was in the comics, Fantastic Four, and heal me, make me a superhero, and I was like crying and stuff. And something happened. I don't know what the hell happened, but all the weird stuff I've seen, something happened. Now I need an upgrade to our mech suit because I'm getting on 50 and I feel 100. So they need to be amping the superhero stuff up a little bit more lately. I'm in retirement. But I'm kind of curious when it comes to quantum physics and superheroes, and I know you're into comics and stuff. Where does your mind go with that? I mean, it seems like it's a possibility. Sometimes I get mad and I'm like, why aren't there superheroes like in the comics?
Why can't I
does man have to dream this up? Why can't God do it? And why isn't there a Fantastic Four to kill Putin or whatever?
Yeah, right. Well, if the first superhero happens to be Russian, then maybe we're in trouble. The deal is this, right? That's the comics, the stories, the science fiction. That's where Einstein was talking about imagination being more important than knowledge, right? We imagine things that we can't build yet, because someday, if we've imagined it, we might be able to build it after all. Star Trek, today we all have communicators.
Yes.
Remember, we used to wonder what's going on. Now our communicators are even more advanced. We don't have to flip them open. We can just tap them.
Unless you really want to, they do sell a product. I forget what company, but it's a Bluetooth Star Trek communicator. The gold lid, you flip it up.
Really?
Swear to God, it's like $200 or $300. Yeah, I'm gonna get one. They're worth it, and it Bluetooth to your phone, and you flip it open, and you don't know who's calling. So when you flip it open, you don't know with your phone. You go, oh, I don't want to talk to him. Right? With that, you don't have that possibility. You flip it open and you automatically start talking. But still,
right. So super technology or superheroes and so forth. If we think about them and imagine their existence, the possibility of their coming about just might happen. Now, we know now, right? In 1961, when Stan Lee and Jack Kirby first invented the Fantastic Four, they had no idea what cosmic rays do, right? We now know if you get bombarded by cosmic rays without enough shielding, you don't turn into somebody who can stretch around and somebody who can become invisible and make force fields, okay? You die, right? Your body gets ripped up, your cells stop working, and your networks, kind of just fail. And so we know that that doesn't work anymore. So we try to find other ways, right? But nevertheless, you wind up with one step after another. And when the human imagines, right, then the human can eventually create. Um, Cyborg, the Teen Titan, right?
Yeah.
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 He's built up with all kinds of different pieces of stuff. And yes, a typical human being with prosthetics can't exactly fire white sonic noise out of their fake hand or their prosthetic hand, right? But you've seen how people with prosthetics legs now, they put those running blades on, they can run faster than you and me, right?
We actually have talked about this. Some of my sports friends and I. Not only because of the blade. The blade I think helps, but even if they had a artificial leg,
that's right.
it wasn't a blade, or two artificial legs, and they're running. They have that much less mass. Number
That's
one, the legs I don't think weigh as much as your actual real flesh and bone would weigh. And number two, their lungs and heart aren't pushing blood through that much more extremities.
Right. Good
So
point.
they have, their energy goes a little further, and they can maybe, put more into that thigh muscle to go faster and also longer. So that's part of it.
Yeah. So Jeff, these superhero technologies might already be here, just in ways that we don't quite recognize, right? Instead of thinking, oh, geez, the poor guy has no legs, lost him in an accident or whatever, we might instead be thinking, wow, this guy doesn't have to push as much blood around and carry as much mass around. He's better than we are, that kind of thing.
Well,
so
are you familiar with Martin Caidin?
No, I'm not.
Okay. Are you familiar with the book called Cyborg?
The original one, the $6 Million Man, was based on?
Exactly right. Martin Caidin is the guy who wrote it. He was he worked he was one of those Area 51 type guys. He worked on some of the space flight stuff. He was actually one of the guys that was, I don't remember what the project was called. It was L2A43 was the flight lifting. It was called the lifting body. And it's the ship you see that does this in the beginning of the big man and it crashes. Yeah. He based his story on that gentleman's test flight who survived. And I think he had some bumps and bruises and maybe broke a leg. In the book, he loses both of his legs. Mid-thigh. He loses his left arm, not his right arm. In the TV show, it's his right arm because Lee Majors wasn't left-handed. Lee Majors
is right-handed, yeah.
So he loses his left arm and left eye in the movie. In the book, in the movie TV show, it's exactly opposite. But he puts all the stuff back on. And they say this about him, that the arm looks exactly like his original, the legs look exactly like his original, his feet, toenails, all, so that no one would ever be able to tell the difference. He knows that they're mechanical and, but they're nuclear powered for one thing.
Yep.
But Dr. Wells in the book, because I read the book, the Dr. Wells in the book says, remember now when you're going to have all this extra energy because you're not pumping blood to your two legs and your arm. So you're going to have to learn new ways to control your breathing. Otherwise, you're going to have a heart attack and die, and we're going to lose our $1 million.
Wow.
So you probably have to, if you lose a major part of your body, both arms and legs, you probably have to have some breathing techniques so you don't, if you overexert yourself.
Yeah, that makes a lot of sense.
Yeah.
Do you remember seeing the pilot of the $6 Million Man followed by the actual TV show $6 Million Man? The Rudy Wells character was switched out. It was different. Lee Majors was still playing the same guy, but it was a lot of fun to see the differences. And of course,
when they got two Dr. Wells throughout the show,
they wound up with different Rudy Wells, and they had created that Oscar Goldman character, which was more the political guy.
Came in after the pilot,
scientific guy. That was a great show. I thought it was awesome. And of course, Steve Rogers was an astronaut in the TV show, which just
astronaut, and then awesome. former astronaut turned test pilot. That's
Steve
when
Austin,
he got injured.
That's Steve Rogers, who's Captain America. That's a different guy.
they kind of did in the first two shows or whatever, the first few they kind of try to do the book, but in the book he actually gets into a bionic. He gets into a bionic dolphin. And he has a drone dolphin that follows the drone, the one he's in. It's like he gets shot out of a torpedo tube from a submarine into the Middle East to go cause some havoc or whatever, rescue somebody. I forget what the exact mission was, but he uses a fake dolphin to get through the enemy's like navy. It's just the weirdest book ever. But
you gotta love that. You gotta love that sci-fi from that era, right? I mean, and even now we're always pushing the edge.
I was trying to segue. And I'm sorry, I'm taking a little time. I was trying to segue into we're at the point now with prosthetic technology that, and I think Elon Musk is in on this. They're trying to get the brain to talk to where you connect, and then that connects to another microchip, and then you use your brain to open, and they're very, very close. So we're at the point where if I were to lose a leg tomorrow, or maybe 100 years from now, when we have immortality almost, you just get a new arm, new leg, and just think about the possibilities where we will go, and possibly even turn ourselves into the Borg of going back to Star Trek.
Yeah. We won't be there for generations yet, but certainly
I think we're a ways off. Yeah, but
it's on the way. Elon is not. Yeah, Elon is not the first to try to do this kind of neurobionic stuff, and he won't be the last.
Mm-hmm. There was the one guy who did put a chip in his brain so he could try to control his mouse or his computer, because he was like, he could barely move his arms or what have you.
Right.
And he was able to move. I mean, he doesn't touch the thing, and you can see the mouse move on it, and it's creepy, but he does it.
Well, it's not that creepy at all if you think about the physics of it, right? Our bodies do have electricity coursing through us in the same way that a computer does, or a prosthetic arm does, or a mouse does. It's just at very different electrical levels. So I was talking to someone that I had the pleasure of interviewing. Her name is Dr. Nikki Driscoll. She and a guy named Dr. MJ Antonini, they have a startup in in sort of near MIT in Cambridge, Massachusetts. It's called Neurobionics.
Oh, cool.
And yeah, they are pretty amazing. They are literally doing.
Oh no, he froze.
Oh no.
He froze.
Probably in cryogenic sleep. I don't know if you can hear us, Charles.
Yeah, Charles. Yeah, your camera froze up.
Yeah, you froze. But I was going to ask him if he needed to go soon, because I know he said an hour. So we've already gone over an hour.
I think he's enjoying. Well, let's see. He may be able to see private chat if he's still on the.
Maybe an internet issue. But I didn't know about those cyborg books. I'm looking at them; they're kind of expensive. But I mean, there's some that might be.
It's been a while. I had the first one in my books before my brother made me throw them all away. But
oh my God, are you kidding me? Oh my Lord! But hopefully he comes back, and
yeah, that would be cool. Hopefully so.
Internet trouble, but good interview, and got it sparked up. But yeah, those cyborg books look pretty interesting. I'll have to check them out.
You might be able to find them cheaper if you go to like a sci-fi con.
I didn't know there was even books called that. I had no idea.
Yeah. Oh yeah. I think I bought my copy of it at Shore Leave in Baltimore many years ago. Some guy was selling books, and I saw Martin Caidin Cyborg, and I looked at the back and said, "This was based on this. They based the TV show on this." And I'm instant snatch, like $3.
Definitely a good interview, great guest, and I was trying to make sure he wasn't one of them Skinwalker Ranch people. Start talking about aerospace and stuff. I was like, you know about that?
Yep.
You ain't worked there, did you? Don't sound like you did.
Don't sound like you did. No.
Yeah, but definitely interesting for sure. Sounds like he has some Spider-Man comics that are old too. That sounds cool.
Yep. I used to have some good old Spider-Man comics as well. They didn't make the purge.
Man. But we'll see what happens. His book is Charles Liu, Ph.D., The Handy Quantum Physics Answer Book, and Visible Ink Press. And let's see.
That would be available on Amazon and other good booksellers.
just told him if he wants to come by and say bye. If he gets a chance, he can. If not, I'll plug his book and like to have him on again sometime because he seems like someone you could just talk to forever about all kinds of stuff.
There it is, the handy astronomy answer book. Very cool.
I wanted to ask about dark matter and dark energy. What's the difference? I don't really know.
Oh yeah. I'm not sure science is even to be able to come up with a postulation yet. I mean, it's some of it's so brand new.
Saw something weird about dark matter entities. Like, can you like something may live in that in like dark creatures? Matter?
Well, I mean, if you think about it, we have extremophiles that live in all kinds of climates here on Earth, so it's why not?
And yeah, there's all kinds of weird stuff. So could be some Lovecraftian entities that live inside the dark matter.
Might find the gibbering mouther. Ugh, what an ugly thing he invented.
Trying to watch some good Halloween movies. We saw a weird one, Phase 4 from 1974. You ever seen that with the ants?
Oh, probably. I think I did. Yeah.
These ants
were like in a biolab and they go hog wild or something like that.
Yeah, but the ants stay little. I thought they'd at least grow real big. It's just a weird.
It's
weird
just cheaper to have what you're going like this. Oh, they're killing me, and you don't have to draw anything in.
Ants start building like Stonehenges and shit.
Do they?
They start building like ancient alien stuff. It's really a weird 1974 ant movie called Phase 4. And then these guys were like hunting ants down with bioweapons and stuff, and that's crazy. But some good stuff. What else have I been watching? Oh, I saw the new Hellboy. It actually wasn't bad. I thought it was. I thought it was better than the last one that they did.
It's not the same guy playing Hellboy though this time.
No, it's a different dude. It's the Hellboy, the Crooked Man. It's by the same guy that did those Crank movies with Jason Statham that are crazy as hell when they're like supercharged and stuff. It's called the Crooked Man. It's in Appalachia. There's a lot of Appalachian witchcraft and crazy creatures and like Appalachia. I liked it.
It's where I wouldn't say about the region where I'm at is in the Appalachians, nearby them anyway.
I still want the Guillermo del Toro ones, but this one was fun to watch. I thought the last one wasn't that great by Neil Marshall. The guy that did Dog Soldiers with David Harbour. It was okay, but
I like Dog Soldiers, but I wouldn't. It wasn't awesome. It was good. Yeah.
Yeah, we're supposed to make a sequel to that at some point. Dog Soldiers, a werewolf. You want a good werewolf movie? Look for Late Phases. That's a good one. It's called Late Phases with a P. Late P-H-A-S-E-S. This blind guy goes to an old folks' home that's being attacked by werewolves, and he's old and he has to protect the old people from werewolves in the community. It's actually pretty good. There he goes.
I'm back. Just out of nowhere, we lost power.
Oh gosh,
completely lost power. We but it's back. It's a weird blackout and backup kind of situation. So sorry about that, everybody.
No
it's okay. You cryo freeze like Han Solo. There, you're like.
Well, I was talking about Neurobionics, right? This startup in Cambridge, Massachusetts, and what Dr. Driscoll was telling me. She was explaining that the human brain has electrical signals of about 100th or 1/10 of a volt. Okay, so you know how we have a 5-volt batteries or 1.5-volt batteries that we put things in, and our devices are several volts. Well, it turns out that if our brains run their electrical systems with voltages that are quite small, maybe like 1/10 of a volt or so, but our muscles and our skin also produce electricity. And so you wind up creating this sort of noisy background. So when you're trying to read your electrodes in your brain, if you just have stuff on the surface, there's so much extra noise that it kind of blocks out the signals. It's almost like trying to listen to a radio, terrestrial radio on AM or FM when you're 100 miles away from the station. So you get a lot of static and it's a lot quiet. And so what they're trying to do is to find ways to cut through that static, right? And give the opportunity to get a device into the brain so you can stimulate it to help stop epileptic seizures and so forth. But by going through blood vessels or coming not invasively through surgery to try to get those electrical signals where you can actually contact them and be in touch with them. It's amazing technology, which I hope that we will all be able to use someday to help us all out. Yeah, it's amazing.
Very, very cool. And now you brought up a very interesting phenomenon that I got to ask you about, because I'm sure you know the answer. I'm pretty sure I know the answer, but I don't know. I don't remember how it works. You brought up the AM station where you're trying to listen to your favorite station 100 miles away. All you get is.
Yep.
What about those times in the certain weather conditions and you're driving down the road and you turn on the AM station and you pick up Chicago and you're in Savannah, Georgia?
I used to love
Georgia,
that.
600, 800 miles away. How the hell does that happen?
Yeah.
I remember being explained to it in meteorology classes, but
great question. The answer is the upper atmosphere has a magnetic field running through
magnets
it. Right. Our Earth is like a giant magnet. Right.
Mm-hmm.
It's not very strong. It's only as strong or even weaker than a typical refrigerator magnet at any given point. But because our Earth is thousands of miles wide, the result is that you create these fields around us that under those right atmospheric conditions will actually bounce the AM radio station signals that ordinarily would just go off into space. It would actually bounce off and come back in an echo, sort of. And that's why you could get Chicago from Florida or New York from Tucson or, whatever. It's a really neat effect. I don't know if you guys heard that there was Aurora, Northern Lights yesterday.
One of my friends at work took some pictures out, so not far, like half an hour away from here.
Amazing. That's great. Yeah, so that is what happens when star stuff, or more particularly stuff from our star, the sun, comes flying toward us after a solar flare or a coronal mass ejection, it's called. And when it reaches all the different structures of Earth's magnetic field, it streams those particles toward the north and the south poles. And so you wind up creating these cascading lights because all that energy is interacting with the molecules and the atoms in the upper atmosphere, creating these bands of different colors. So it's really
here's an interesting postulation I'd like to give you that I came up with, and Giorgio Tsoukalos got mad at me and kicked me off his friends list because of it. But for whatever reason, that it was highlighted the Naranja, the Aranya glyph in Nazca, the spider glyph. And everyone's saying, "Oh, it's a spider. It's this kind of spider." And I forget the name of the spider, but the type of spider that is still alive of that species, it's a reticulated spider, but I forget the scientific name. The only known species that is alive today is in Western or Northern Africa.
Wow.
And the largest example is 10 millimeters in diameter. That's how small this spider is. Very, very small. Yet this large glyph on the Earth has, on its third leg, it has an appendage coming off, which is what it uses to mate with the female of the species.
Wow.
In order to see that, you would have to absolutely have magnification. You have to be able to see this spider. And it would have to live on the Peruvian Nazca Plain where you can observe the spider to draw it on the ground, number one. So everyone thinks it's this reticulated spider that's from Africa. That there are some maybe ancient species of that used to live in South America, but no one knows for sure. My postulation is because if you look at every artist rendition of the magnetosphere, the Earth's magnetic atmosphere, it looks shockingly like Spock's moire pattern, that white and black thing that spins on his console. Looks shockingly like that, A, and B, so does the spider. And I put a picture of both of them up face to face on his thing. I said, "Hey, Giorgio, look, you're almost identical. It's not a spider. It's the magnetic atmosphere."
Wow.
I was zapped off his Facebook page.
Isn't that funny?
But that's my postulation is why is this thing there? Who cares about a spider that's, less than unless it's like the deadliest thing on the planet and almost wiped out the Mayans? I don't know. What do you think of that postulation? What does the atmosphere look like? Is there a way that we can measure it and and find out what the moire pattern is?
That's a great question. Like we were saying earlier, our feelings about archaeoastronomy, right? Thinking about our ancient ancestors all over the world and the amazing things they did, the Nazca lines and all the stuff that we find in Peru are really quite remarkable. And actually, I saw in an article, it's a shame, there's some people who have like no regard for that kind of history. They've been doing illegal sand dune races in dune buggies,
Oh
and they've
God.
been like creating these terrible streaks across these beautiful lines.
Oh, that's horrible.
It was horrible. But anyway, yes, those lines, if they match the magnetic field of the Earth, then they will also match the magnetic field of a bar magnet with iron filings on it. So if, for example, you put a lodestone, a magnet,
Yeah.
on a flat surface, and you sprinkle iron shavings or other metallic
You get an
material,
Aranye
you
glyph. You get
get
a spider.
you get shapes
Yeah.
that look like what you might describe as a moire pattern or spider, because there is indeed that kind of effect that happens on small scales as well as big. Now,
Yeah.
Earth's magnetic field, because Earth is a three-dimensional structure, has
Yeah.
that kind of shape, but not flat, but all
Yeah.
around in like
Yeah.
a
Oh,
huge
yeah. It's
donut.
huge,
Right.
and it's enormous on top of
Right,
everything.
exactly. So they probably wouldn't have been able to see the whole Earth stuff, but they surely would have been able to see some of the stuff just laying down on the ground. Now, I don't know if there's any records to show whether they had a magnet like that to look at, but certainly I don't have enough background to know whether or not that is a reasonable idea
Yeah,
or
we
not.
know historically, at least with what we've done, archaeologically wise, that the hardest thing they used was like obsidian. When there's a chipped stone that they put into their clubs and wood and things and used as a knife.
Hmm.
So there's no evidence of steel, iron,
Right.
any meteorites of iron background of that kind of nature. There's iron meteorites all over Europe, so maybe just the northern, North America, South America just got hit with the different type of rock material from space. But yeah, none of that.
Yeah, it's a great question. Perhaps all their material that they had that were iron and lodestone or magnetic and so forth was lost somehow.
Is
And
possible as well, yeah. But somehow that here is this spider glyph that looks shockingly like a like you said with the iron filings,
yeah,
and we don't know what the Earth's atmosphere looks like
wow.
magnetically, but imagine if we could put the Earth and its magnetosphere on a nice white piece of paper and drop iron around it.
Yep, yep.
Maybe we could see it. Maybe it would match. That's my speculation, is that they both
It's
match.
possible. Yeah,
Yeah.
it might be true. I wish I had more information. I just don't know. I mean, we
Yeah.
do know that particular civilization was especially good, I mean, even better than other civilizations that we know who did this very well, that they could figure out in their head, they were able to map what they see
Mm.
in a small space out into these huge scales, right?
Yeah.
So you don't have to have a satellite map or a satellite view of something to know what it looks like from a high distance, because you can have that mapping. And they were able to do this for scale stuff, the kind of architectural work that you're really good at, right? Things
Yeah.
to scale and so forth. They apparently were so good at that they could draw these lines that were remarkably realistic and amazingly intricate, even though they couldn't actually fly up and see it from
Well,
3,000.
some of the early speculation was that they had some sort of they used like an animal bladder or leather skin or some kind of whatever. They didn't make their own textile, so it would have had to have been an animal skin
Wow.
filled with a gas or a hot air, and or even used as like a sail. Some guy's like sailing up here and he's directing. All right, turn left. All right,
Wow.
turn right. All right, you can stop.
I
That was the early spec. It's like, no, they didn't. There's no evidence of any type of balloons or
right,
air sailing or
right.
any of that in any of those cultures in North, Central, or South America. So
Mhm.
great idea, but pure fantasy.
Yeah, yeah. Just follow the technology of mapping, the mathematics of geometry that all architects and all designers use today, and they were just really good at it. Yeah. Uh, that's so cool. Oh,
Mhm.
wow.
Yeah, and one other cool thing I can tell you about South America, Central
Mhm,
America, North America, and ancient Japan and Korea.
mhm.
So in art school, I took a couple of Asian Oriental classes, and
Uh-huh.
one of the classes, the teacher wanted us to write something about the art. I don't remember what the origin was, but she wanted us to write a story about a type of origin of art. So I didn't know much about Oriental art at the time, so I researched the Jomon or Homon people, and it translates to the rope pattern or rope people.
Okay.
And because I'd always wondered, I'd always seen this pattern all over the world. You go to an Italian restaurant and you see that L border, it made of rope or whatever, or waves, even depending on the theme of the restaurant. But it's an L-shaped themed border. It goes all the way around the placemat. Well, that border, that rope border, started 12,500 years ago in Japan.
Is that so?
Started in Japan, and they did it. They put it on their pottery. They put it on their plates. They decorated whatever textiles with these patterns, and you can follow it. They made dugout canoes.
Oh.
What other race of people on the planet do you know who make dugout canoes?
Oh, a whole bunch of them. Native Americans in America.
Native Americans, number one. This is where they got this is where the technology comes from.
Wow.
So the Japanese forebears, the Homons, would build these canoes and then make caravans or convoys, and they would go with the easterlies or whatever they call the underwater trail, if you will. They would follow that along the Aleutian land bridge through Alaska, Canada, and North America. And then as they're going, they have it wasn't just one guy, it was like a whole family or a whole village even, and lots of boats, lots of goods, and they would trade with the peoples native to the Alaska, Canada, North America, all along the way. But it took a long time. It took probably a year or more to go maybe years.
I imagine.
And they probably spent more than a day, maybe weeks, months with these people that they met on the shores, and interbred, which I didn't know, interbred, and I'll get to that. But they traded their goods, which are they call them ding. It's a pot, and it's typical of three. It's got three legs, and it looks like a witch's kettle.
Oh.
Okay.
Oh.
Now, where in Mexico do you find a three-legged kettle?
Oh, quite a few places, right?
Go to any Mexican restaurant. And instantly, when you sit down, you are given a glass of water, a bowl of chips, and a three-legged urn with salsa dip.
Isn't that something?
That came from Japan and Korea.
Wow. The connections that those ancient humans had.
Yeah. And we were interconnected even before we thought we were interconnected. But great. Those rope patterns that they put on their ding, their vessels, they sold them and gave them. They brought their goods like foods and seeds and fruits that they traded, and their artwork and their textiles.
Wow.
Those went into North, Central, South American Indian villages, and you still see those rope patterns. Buy any Peruvian poncho.
Yes.
You're going to see that borders all around it that you can track back to 12,500 BCE.
Wow. Wow.
And it goes all the way around the Pacific Rim, and then it flushes across the Americas, and then over to Europe.
Amazing.
And back around all the way. It goes from far east to west, all the way around the planet.
History shows us over and over again. Yeah.
Here's the thing that shocked me is in 2013, or when it was early, the Human Genome Project finished their project 2 or 3 years early, and they announced that the Native American Indians, North, Central, South, Alaskan, Canadian, Peruvian, are more genetically connected to Japanese and Korean haplogroups than they are to any Hispanic, Spanish, Italian, or English, or European haplogroup.
Amazing.
There are people in Argentina and all the way down to the tip of South America. You look at them; they look exactly like Japanese people, but they are very, very brown. That's the only difference.
And
it was shocking to me that I was like, "Oh my God, the Japanese people connected the planet."
Yeah, they really did. The more we've learned about the history of humanity, the more that we see that all of us are have much more in common than we have apart. You're much more similar than we are different. It's really quite remarkable.
We fight over the stupid.
Hey guys, we got about 4 minutes. So.
Oh no, Jay, this is so much fun. You're
know,
so right. We argue over the stupidest things. I mean, when we have so much in common and so much joy that we can share.
My land is better than your land. My God is better than your God. My money is better than your money. You know.
Yeah.
I mean, a beautiful interview. We'll definitely have to get you back sometime. It's been really great. And next week I got Paul Wild on Jim Morrison, Occult Teacher, about the doors. I'll have to send you that. It's going to be a good one.
Baby, light my fire.
I didn't even realize that, and I mentioned the doors early on.
Yes, you did. That's right.
But Charles, it's been great, and I love it. And thanks for teaching us. And you're the coolest teacher. I'd take you for a teacher back in my day, man, for sure.
Oh, you're so kind, Jeff. It's such a pleasure talking with you guys. Thank you so much for having me today. All right.
And that's the handy quantum physics answer book. Charles Liu, Liu. I'm saying that right? Liu?
Perfectly. Yes.
Okay. I'm from Georgia, so I got to be careful.
You did great.
Liu. But I appreciate it. Thanks so much. It's been a great show. Do you have a link or anything like that? Or
the best way to contact me is through the Luniverse, which is my social media channel for my podcast. So it's THE, and then LIU, my last name, and then NIVERSE. So the Luniverse.
That's very clever.
Yeah. I didn't think of it. It was my family. My kids said, "Hey, you should just call it the Luniverse." I said, "Really?" They're like, "Yeah." And I was like, "That sounds weird." But I talked to my producer folks, and they were like, "Totally do that." Like, okay, all right, whatever happens.
Now that kid's getting a stipend every week now, yeah?
I hope so. At least paying for college education, something.
I found it on here, YouTube. All right, that's the LIUNIVERSE. Check that channel out on YouTube. Thanks so much, man. It's been a great one. We appreciate it. Thanks.
Thank you, Jeff. Thank you, Jay. What a pleasure. Have a great night. Thank you.
You too. Take care. Bye-bye. All right, everybody. You're listening to United Public Radio, 107.7 FM, New Orleans. Next week is that Jim Morrison Doors show. And then the last show for Halloween is Dagra Mason, Father of the Crossroads, the Song of the Dark Man.
Yeah, I saw that in the queue.
That title gives me the creeps.
I immediately thought of Liam Neeson in the movie Dark Man. That was a great movie.
He's in the UK. It's a lot of paganism stuff about Halloween and things like that. But definitely going to be a good Halloween show. And then we have what coming up? Let me see what's going on. Energy Magic Show.
Oh, cool.
Mark Nakamp, Ellen Everett Hopman, that's Celtic. Ricardo Delgado, that's some Dracula stuff. Christina's coming on at some point. Betty Page, and then I just got Ronald Murphy from Small Town Monsters, and that's you'll be there for that show. I need to get the PDF. I'm still doing December and everything, but that's it so far. But thanks everybody for listening. You're listening to United Public Radio, 107.7 FM, New Orleans. Everybody have a good weekend, and we'll catch you next Friday with the Doors. Good night, everybody.
Good night.
Happy Halloween. It's here. It's actually cold in Florida, 62 at night.
Cold up here, dude.
I'm so damn glad. All right. Catch everybody later. Thanks.